Alright, let's solve some percent of change problems. And I've got four problems for us, and they're of different types. So just kind of give some practice of the different kinds of percent of change problems you'll come across. And the basic format of what we're going to be doing um, is this: the percent of change is the new number minus the old number over the old number. Or you can think of it as the amount of change, plus or minus. Delta means change. The amount of change. You know, if it's gone up by two, the amount of change would be two. Uh, Divided by what the number used to be. Kind of old is the percent of change. Okay. Need to pay attention to whether it's an increase or a decrease, a positive change or a negative change. Okay, so let's go through some examples. We'll follow this model. Some of this will just, it might not necessarily require that we set up a full equation. Anyway, let's just go through it and see how it goes. So last year, 5 of my blueberry bushes produced berries, and this year, 7 of them are producing. By what percent did the number of producing blueberry bushes grow? Okay, so let's just look at this intuitively. Last year, 5 were producing. Um, and now that's gone up to 7. So what's the amount of change? The amount of change is plus 2. Okay? What's the original amount? What did I start with? 5. So 2 over 5 is the percent of change. So um, 2 divided by 5 is 0.40, and 2. So you could leave it as that, or if you wanted to write it with a percentage sign, you move the decimal over to the right 2. So this 0.40 is 40%. So an increase of 40%. It's a positive percent of change there. Okay, let's keep going. So you see, I didn't really write out this new minus old business. I just kind of intuitively, we know it went up by 2. Um, you could have written that out as so if the new number is 7, the old number is 5 over the old is the percent. That'd be writing it out completely. So 7 minus 5 is 2. 2 over 5 equals x. 2 divided by 5 is zero point 0.4, and that's 40%. All right. Okay. So sadly, 25% of my chickens died when a fox, uh, a fox attacked. I need to edit that better. Attacked the chicken coop last night. Wow, I was half asleep when I was writing this. Chicken coop last night. 5 whole chickens became fox food. How many chickens did I used to have? Okay, so now, uh, what? Let's look at what we know. We know the percent of change, um, and we know, um, we don't know the new number, and we don't know the old number, but we know that the new number minus old is -5. Um, so think about that. So if the number of chickens went down by 5, and my top part of this is the amount of increase or decrease, I, so I would just write that. Whoa. Um, so my so the new minus old. I don't know how many chickens there are now. I don't know how many chickens there used to be. But I do know the difference between um, what there are now and what there used to be. I know that now there's 5 less. So this is a decrease of 5. That's why I put in negative. So there's 5. I lost 5 chickens. So -5 out of however many chickens I used to have. which is what I'm trying to answer. How many chickens did I used to have? So that's going to be my variable. Negative 5 out of something is equal to what? Uh, Negative 0.25. That represents a decrease of 25%, uh, which in the decimal equivalent of that is 0.25. Okay, so now I could solve that. Maybe I want to get x out of the denominator here, so I multiply by x. Well, let's multiply by x, multiply by x. Negative 5 equals negative 0.25 times x. Now I could divide both sides by negative 0.25. Negative 0.25. These negatives will cancel out, so on the calculator I'm just going to do 5 divided by 0.25. That's 20. X equals 20 chickens. So think about it. Let's check it. I've discovered that I used to have 20 chickens. Um, I went my number of chickens last night went down by 5. So now I've got 15 chickens, right? So my new number of chickens is 15. I used to have 20. So 15 minus 20, the new number minus the old number, over the old number is the percent of change. Um, so if I do 15 minus 20, that's negative 5. Negative 5 over 20 is um, negative 0.25, and that's what we said it was, a change of a negative change of 25%, or a decrease by 25%. All right, let's keep going. The bear population of northern Minnesota has increased by 200% since the 1980s. Okay, so we know the percent of increase, percent or the percent of change. So it's positive, and it's 200%. So if I'm going to turn that into a decimal, I'll call that 2.00. If I take 200% and move the decimal over to the left, we get 2.00. Okay, so it's increased by 200%. Now there are about 25,000 bears. So I know the new number. How many did there used to be? I don't know the old number. So the new number, 25,000 minus the old will represent the change. Um, so new minus old over the old. Um, don't know that, so I'm gonna call that x. And so let's solve it. We could consider this a proportion, just cross multiply. So I've got 25,000. So 25,000 minus x times 1 is just 25,000 minus x equals 2 times x. All right, so let's add an x to get the x's all over one side. We're subtracting x here, so we're going to add an x. So 2x plus x is 3x. What's left over here is 25,000. So 25,000 is equal to 3x. Now I just divide by 3 to get x. So, um, oops, ignore that, ignore that, ignore that. Hold on, let me pause. Sorry about that. So 25,000 divided by 3 is 8,333.3 repeating. So, um, so approximately, what did I just say? Um, 8,333. Okay, so that's a positive increase there. So yeah, they were less than 10,000 a while ago. Now it's up to 25,000. So that's good. All right. Um, I'm going to let you solve this one because I'm taking a lot of time here. You've got 20 red pandas. Tomorrow you're going to give me 10% of them. How many will you have left? So you're solving for what's the new number of red pandas. It's going to go down by a certain number, and that's going to represent a certain percent of change. Why don't you see if you can solve that following this model, following what we've done. All right, good luck. Have fun. Red pandas are awesome. Check plus. Yeah, they're really cute. All right, see ya.